Okay. All right. So I'll lower the screen again. Hopefully that won't happen. Second time. All right. So so we know the polynomial, right, is going to look a little bit like what? So it's got to have 4 factors, right? Because it's going to be 4th degree. And we were already told kind of what those factors have to be, right? So we have what? X plus 3, right? See, that's easy, x plus 3. And then what else here? X minus 0, so that's really just x. So one of your factors is x. And then x minus 1, right? And then also x minus 5, okay? So, so basically, that's the form of the polynomial. But the tricky part here is that that initial condition there that's given is that P of 2 has to be equal to 10. So they're not telling us about the y-intercept here. They're not giving you P of 0 is equal to something. That would be the y-intercept. But this is essentially the same. They're giving you information about 1 point on the polynomial. So we have to check this, all right, to make sure this is correct. Before we know we've got the right answer. So so let's try this and see what happens. So if you actually plug 2 in here into this formula, don't simplify the formula, leave it in factored form. What would you get? You would get 2 plus 3, right? And then 2, which is the same as 2 minus 0, so just a 2 there, right? And then a 2 minus 1, correct? And then 2 minus 5, right? So what is that actually? What actually is that product? So that's what, 5 times 2 times 1 times a minus 3. Is that 10? Oh, darn it, no. What does it turn out to be there? That's minus 30, isn't it? So something is off, right? Okay, because we want the P of 2 to be 10, not minus 30. So we may think that they've given us an impossible condition here. We might just think, well, there's just no way, right? So maybe the answer to this is doesn't exist, right? Maybe this, maybe they just asked for a polynomial that there's no such polynomial, okay? Or is there some other way that we can alter this formula so that P of 2 will be equal to 10, but we cannot change the factors, right? Okay, we cannot change the factors because we have to have these numbers as x-intercepts. So you cannot change the factors. So that limits you a lot in what you can do, right? Okay, you can't change, you can't add a factor because that would give you another x-intercept, right? Or that would change the degree, correct? So, so we cannot add a factor here either. So the question is, what can we do? Here's what we kind of overlooked. Although when you factor this polynomial, you have to get these parentheses of factors. We can also have one other factor in here. It cannot involve x though. So it's possible that we could have a constant factor here in this formula, right? So you could have a number multiplied by the x plus 3, x minus 0, x minus 1, x plus 5. It can't involve x, because if this factor involved x, then you would have 5th degree, but we can only have 4th. But we could have a constant here multiplied in. That's what we kind of overlooked. So maybe in this factorization of our polynomial, there's a constant in front of the factorization. It could be 2 or 1 or something. Not 1, that doesn't make sense, right? But 2 or minus 2 or some factor multiplied in here that would make the P of 2 equal to 10 and not minus 30. All right. Okay, so let's think about that. So suppose we have a constant multiplied in here, and now let's evaluate P of 2. So keep the constant. You don't know quite what that value is, right? But keep that constant. Plug the 2 in. So you still have this constant multiplied in. So you have a times 5 times 2 times 1 times minus 30. And notice when you multiply all of those numbers together, you get minus 30 again times a. The a is still multiplied in there. But what is that supposed to be according to the instructions? What's that minus 30 times A supposed to be? 10, right. So this is supposed to be equal to 10. That's an equal marker. So the minus 30A is supposed to be 10. Oh, then I can solve this for A, right? I can figure out what A has to be. Just divide both sides by minus 30. So you get 10 over minus 30, which reduces to what? Is that minus 1/3? Yeah, that's minus 1/3. Oh, so minus 1/3. Oh, so here's my correct formula. It wasn't just x plus 3 times x minus 1 times x minus 5. It was supposed to have in front of that a minus 1/3. So just put that into your formula. So you have minus 1/3 times what? This is x, so let me write that first. So this is x first, and then x plus 3, and then what? X minus 1, and then x minus 5. So there's the correct formula for the polynomial. It has that extra factor of minus 1/3. And with that extra factor of minus 1/3, then you will get P of 2 is equal to 10, just as we wanted. Ooh, let's try that again then. We have just enough time before we break here. Let's try that again. I think I have another problem like this one somewhere way down in these notes. As a practice problem here. Somewhere. Move things around here so I can get to that. Oh, there we go. All right. So I want y'all to try this one. It's almost the same. Here we want a polynomial of degree 3, and we want its x-intercepts, its zeros, to be minus 1, 2, and 4. Right? So that's kind of obvious what that polynomial formula is going to look like, right? But the other condition is the one we have to be careful of. P of 0 is equal to 16, right? P of 0 is equal to 16. That's the y-intercept. P of 0 is the y-intercept. So we want a y-intercept of 16. So remember, when you write down your formula for your a mysterious polynomial here, right? You know you're going to write down a bunch of parentheses here, right? Because you know what your x-intercepts are. And then don't forget, also leave yourself space for a mystery constant, all right? There has to be a mystery constant there that you can adjust so that your y-intercept will be 16, okay? So write this formula down first and then see if you can figure out what do you have to make the a be, right? So that you get P of 0 to be 16, or maybe P of 0 starts off as 16. Maybe A is just 1. I'm not sure here. I don't know what the answer to this question, right? Okay. All right. So you guys try that. You try that at home. So, and then we'll see what the formula is. Remember, you don't want to expand. You don't want to expand the formula. Don't try to expand this product. Okay. You can leave your polynomial in factored form. That's much more convenient than having it in expanded form most of the time. All right, I'm going to go around and try to prompt y'all if y'all are stuck somewhere. Right. So have to solve that equation. Okay? Set up what? What is that? Zero plus one. So, but all right. So I that's it. Okay. Okay, did pretty good. Did y'all get that at home? Did y'all try that? Did y'all figure out what A is going to be? You know, when you factor this, you're going to have x minus a minus 1, which is x plus 1, right, to correspond to that x-intercept, and then x minus 2, and then x minus 4. But we have to choose the A properly, right, so that P of 0 will turn out to be 16. Did y'all get the proper value for A at home? Someone at home get that? Can y'all check that in? What is A equal to in this formula so that P of 0 will be 16? Did someone type that? Ollie, did you try that? Christopher? Write down my list here. Fernando. All right, so Fernando says 2. Okay, so I've got some people not responding to me. So if you guys are out there and I'm asking you a question and you're not responding, I'm just going to count you absent. All right. So you're not here as far as I'm concerned. Right. Okay. Because you can always say, I didn't find anything. Right. Okay. Or I wasn't able to do that problem. Okay. So you're off watching television or something. You're not really attending. Okay. So Fernando's right there. The A is indeed A is 2 there. Okay. Now, why is the A 2? So most of everyone now sees that already, right? Because if we evaluate P of 0, that's going to be according to the formula A times 0 plus 1 times 0 minus 2 times 0 minus 4. But that's supposed to turn out to be 16. Okay. So when we calculate it, we calculate it this way, but the calculation is supposed to be 16. Well, when you multiply A times these parentheses, you end up with 8A is equal to 16, and then just divide both sides by 2. So there's how you find, right, that A is equal to, there's how you find, right, that it 2. Okay. All right. Now, here's the part that we've kind of kind of not addressed, all right, so far. So suppose that we are just given, a polynomial. This one's not that bad, okay? So x cubed minus 3x plus 2, and we're told to find the x-intercepts, find all the x-intercepts there, okay? And so in that prior homework, right, the one that we were looking at a few minutes ago, the book was making a suggestion to you. You know, they were telling you, oh, okay, try this number and see if it's an x-intercept, right? Okay, or try these two numbers and see if they're x-intercepts. And you know, when you can find 1 or 2, then you know, that usually simplifies the problem. But here we're just, you know, we're just told, here's a polynomial, see if you can find the x-intercepts. And so that makes it very hard to know where to start, right? I mean, where should we start looking for those x-intercepts? Okay, well, that's the secret that I'm going to show you next, right? Is what numbers you can try that may possibly be x-intercepts. All right, now see here, notice once you find one x-intercept, if you can find one x-intercept, then that's going to reduce this problem to just a from a cubic to a quadratic, from degree 3 to degree 2. And once you've got it down to degree 2, then you're in good shape, right? Because you can always find the remaining x-intercepts if you cannot factor by doing what? For degree 2. You can always use the quadratic formula, right? You can always use the quadratic formula. So if we could find 1 0 here, we can find 1 0, then we're sort of certain that we can find the remaining, right? Okay. All right. So, well, that's what we have to take up here in some minutes. So let's take a break, and we'll come back at 11:25, and we'll talk about what numbers we should try then as possible x-intercepts to get us started here in finding the zeros of this polynomial and other polynomials. All right. Okay, let me pause this thing. I hope I can recover the earlier here. Knock on wood. All right, so all right, so let me show you the idea here. So this is also due to our old friend Descartes, who we mentioned previously in the course. So what Descartes showed was if you have a polynomial and it has to have an integer coefficient, so that means whole number coefficients. They can be negative though, all right, but it cannot have you know, fractional coefficients. So you couldn't have like a 1/2 here as your constant coefficient, or a 1/3 here as a coefficient. It's got to be integers, whole numbers, and you know, couldn't be like a square root of 2 as your as your constant coefficient, right? But this certainly meets that condition, right? Because your coefficients here are 1 and -3 and 2, right? So those are all whole numbers. And then what Descartes showed is that if you're going to have a zero that is a fraction, all right, if you're going to have a zero that is a fraction or can be written as a fraction, then that zero has to have the following form. Okay, so Descartes' not saying all of these possibilities are zeros, but if you do have a rational number zero, okay, that is a zero that can be written as a fraction, then it's got to have this format. All right, so here's what you do: take the constant at the constant coefficient, right, and write down the factors of your constant coefficient. All right, so here our constant coefficient is 2. That's an easy number. That's a prime number. So there's only a few ways of writing 2 as a product, right? You can write it as 1 times 2, okay? But you can also write it as -1 times -2, because that also gives you +2, right? So write down those factors. So you have plus or minus 1 and plus or minus 2, okay? Because +1 times +2 is 2, and -1 times -2 is also 2, right? Now, do the same thing for the leading coefficient, right? So write down its possible factors. Well, the leading coefficient here is even easier, right? Because it's 1, and the only way you can write 1 as a product is 1 times 1 or -1 times -1, right? So the factors of the leading coefficient are plus or minus 1. I'm labeling these factors of the constant coefficient is P, and the factors of the leading coefficient is Q. All right, that's just a label device there. And so now what Descartes does then is he says, take the quotients, take all the possible quotients, all the possible fractions you can form from these factors divided by these factors. Those will be the possible rational fractional number zeros of this polynomial. See, that's very convenient, all right, because that really gives you some possibilities to hone in on, all right? All right, so let's see. If you take all of these numbers, so remember there's 4 numbers here, plus or minus 1, that's 2 numbers, plus or minus 2, that's 2 numbers, right? But here there's only 2 numbers, plus or minus 1. So if you take all of these numbers and divide them by all of these numbers, what do you get? Well, that's pretty easy, right? You only get plus or minus 1 or plus or minus 2. Because if you take these numbers and divide them by plus or minus 1, right? They don't change the value. So what Descartes says is, oh, if this polynomial is going to have a rational number 0, maybe it doesn't have any rational number zeros. Rational number means a number that can be written as a fraction. Okay, then it's got to be one of these 4 possibilities. That's it. So this gives you some possibilities to experiment, right? So you can try these numbers and see if they are zeros of this polynomial. How do you do the experimentation? You just have to do it by synthetic division. Okay, so you just have to check these numbers to see if they're zeros of this polynomial by synthetic division. All right, so this part is a little bit of trial and error, but the numbers you have to try, not that bad. You've only got 4 possibilities. Which one do y'all want to start with? 1? Okay, so let's try 1. And if you miss, then that's fine. Just go back and try another one until you run out of possibilities. Now, I got to be careful. Let me caution about what I said here. The rational zeros of this polynomial are these possible numbers. But remember, polynomials can have irrational zeros. Okay, all right. So it may be that no number in this list turns out to be a 0 of the polynomial. We hope it will be, but we're not guaranteed that. What's a polynomial, by the way, that has irrational zeros? Well, here's one. They're easy to write down. look at that polynomial, x squared minus 2. That's a very simple polynomial, right? What are its zeros? Well, how do you find the zeros? You take your polynomial and you do what? You set it to 0 and solve, right? So when you solve this equation, you get x squared is equal to 2, or x is equal to what? Well, plus or minus square root of 2. Square root of 2 is not a rational number. Okay, you cannot write that number as a fraction. Any square root that's not a perfect square, irrational number. You cannot write it as a fraction. So so you see, polynomials do not have to have rational number zeros. Okay? But we're hoping they do, so that we can find them, right? Okay. All right. So you guys said try 1. So let's try 1. So let's see. Let's write down the coefficients. So 1. Don't forget the 0. So don't skip the 0 because you don't have an x squared term here, right? And then minus 3 and plus 2. Does this work? So bring down 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Minus 3 plus 1 is negative 2. 1 times minus 2 is minus 2. Oh, yeah, that works. Okay, so there it is, right? So good guess there. There is one of our zeros. So we know that now we know what? That x cubed minus 3x plus 2, that can be written as what? X squared plus x minus 2 times what? X minus 1. So you see, you've got it partially factored there. And now how do you find, if there are other zeros, how do you find them? Try to factor the x squared plus x minus 2, right? Okay. Or if you cannot factor, you can always use the quadratic formula. But this one factors, doesn't it? Doesn't that factor? That factors is what? X minus 2 times x plus 1. Is that right? Oh, so we had lots of possibilities we could have started with, right? Okay. Because what are all the zeros here? 1 is a 0, right? And what? 2 is a 0, and also what? Negative 1. So we had lots of things we could have started with instead of just 1. Do all these numbers go? Are all these in our list? They better be. Yeah, they all are, right? Yeah. Jack. Is it plus 2 minus 1? Am I? Yeah, you're right. Oh, so that cuts one number out of my list, right? Negative 1 shouldn't be here. But those numbers still in the original list, right? So we didn't quite get 3 x-intercepts. We kind of got 3 x-intercepts because you do have 3 factors here. It just turns out that one of the factors is repeated, right? Okay, the x minus 1 gets repeated twice. So you don't end up with 3 distinct x-intercepts for that reason, because one of them gets repeated. So you only end up with 2. Although we had 3 different factors of the polynomial. All right, see how easy that was? Well, that requires a little bit of practice. Now, let me show you what's going to happen in WebAssign that you're not going to like, okay? All right, but you just have to live with it. Yeah, Amanda? No, because once you had factored out this factor, then you just get left with a quadratic. But that you can factor by inspection. Yeah, that's what Jad was pointing out. This, you can just factor this one just by looking at it, right? Okay, yeah. So no, that because once you had factored out this one, it got easy, right? All right, let's try another one then. Okay, so we may have to hunt and peck a little bit, maybe more for this one. We've got more possibilities. All right, so so we want to find the zeros. This is still cubic. So Amanda, once we found 1, and we factored that out, then we'll be left with quadratic, right? And then, but then quadratic we should be able to find easily, right? The remaining zeros. If the well, let's cross our fingers. Maybe they're not so easy to find. All right, so but you got to start with one. So let's see if we can find one to start with. All right, so what are the p factors? Those are the factors of the constant coefficient. So how can you write the constant coefficient as a product, and make sure you write down all the possibilities, although 6 is not that difficult to factor. So how can you write 6 as a product? Don't forget the obvious one. You can always start with that, because 1 times 6 is 6, right? So write that down first. But don't forget, it's going to be plus or minus 1 or plus or minus 6, because -1 times -6 is also positive 6. All right, now what else? What did you say? 2 and 3? Yeah, that's it, right? So not that many ways to factor 6. Now, what about the leading coefficient? Well, not that many ways of factoring 2, right? Because that's a prime number. So it's only plus or minus 1, plus or minus 2. Now you have to form the quotients. So here you have to be careful that you get them all written down. You're going to get a long list here, right? Okay. But it's not going to be infinitely long. So what do we have? Well, look, you can take all of these and divide by 1. So you're going to get all of those repeated. So you get plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3, all repeated. And then what else? I guess all of these divided by 2, right? So I would have 1 over 2. That's 1/2, correct? And then I would have 6 over 2, but that's 3. We already have that one. Then we have 2 over 2, but that's 1. So we have that one written down. And then we have 3 over 2. So plus or minus 3/2. Oh, so that is 12 possibilities there. Okay. Sounds like a lot, but that's better than infinitely many possibilities. So we have something to work with here. Yeah, Chad. How do you get what? Those are the factors of the leading coefficient. It's, yeah, the constant coefficient is first, and then the leading coefficient is second. And then you just form all the possible quotients there. Now you have to test them. So hopefully hopefully your intuition will be very good. And when you test them, you'll find one quickly, okay? But maybe not, and so you have to be a little bit patient. But fortunately, synthetic division goes quickly, right? So it doesn't take a long time to test. Where do y'all want to start? Now, do you already know that one, Robbie, or did you try that one already? Oh, you just wanted 3. Okay, good. All right, so now maybe that's it, right? So I was trying to just warn you to be patient. So I wanted to pick one that wasn't really a factor, but maybe it is. I don't know what the factors are. So let's write down the coefficients. So we have 2, 1, minus 13, and 6, right? Let's see what happens if we try 3. So we get bring down the 2. 2 times 3 is 6. Bring down, add, you get 7, right? 3 times 7 is 21. And this doesn't look like it's going to be that, right? Minus 13 plus 21 is what? Is that 8? And 3 times 8 is 24. Add together, you get 30. So you're way off, right? Here we have a remainder of 30. 2. Okay. Let me try writing over here. Now, of course, on your paper, you can erase things, and so you don't have to be constantly rewriting coefficients. And do you know that one works? So 2 times 2 is 4, 5. 2 times 5 is 10. Oh, that looks good. Okay. So, oh, indeed. Got it. Right. So, see the remainder of 0. So we know one of our factors is x minus 2, right? So this polynomial factors as what? This quotient, which is 2x squared plus 5x minus 3 times x minus 2, right? And no remainder. Now we can find the other zeros, if there are other zeros, just by restricting our attention to 2x squared plus the 5x minus the 3. And that one we may be able to, we may get lucky, right? And maybe we can do that one by factoring. Or if you want, if you like, you can continue down your list. We've already done 2, right? But 2 could work again. But 3 is never going to work. So once you got a remainder of 30 here, you know 3 is never going to work. But you can continue trying numbers on your list, right? With these coefficients, 2, 5, and minus 3. Or you can just, since this is only quadratic, you can try to factor this one by inspection, okay? Or what's your other possibility? So what's the other possibility for trying to find the roots of the 2x squared plus 5x minus 3, Amanda? So you can try, you can continue trying numbers from this list, or you can just try factoring it by inspection, because this one's pretty easy just to try to factor by inspection, just by looking at it. Or since this is quadratic, Amanda, you can always use the what? The quadratic formula, right? So you have it. So we know we're going to be able to finish this problem, okay? Because this is only second degree. Let's see. Does that one? Is that one? Does that one factor? Oh, it does. So you know you've got to get 2x times x, because that's the only way to get 2x squared. And what is it? What else do I put in here? A plus 3 here. X plus 3, and then a minus 1 there. Yeah, I think that's right, isn't it? 2x times x is 2x squared. Minus 1 times plus 3 is minus 3. And then for the middle term, you would get 2x times 3 is 6x. Minus 1 times x is minus x. So that would give us 6x minus x is 5x. Oh, so that one does factor easily. So what are the zeros? One of them is obviously 2, correct? Right? So one of our zeros is 2. What are the other 2 zeros? What 0 does this result in? No, this one. 1/2, right? And what does that one result in? -3? Were all of those on our list to begin with? Yep, right. Okay. So, but we know that's got to be true, okay? Because Descartes guarantees that's going to be the case. All right. Okay. So, my point was, if you once you had got down to the 2x squared plus 5x minus 3, see, you could have continued with your original list, trying different numbers from this list just on the 2x squared plus 5x minus 3. So you might have said, okay, now I'm going to try minus 3, you know, and use the 2, the 5, and the minus 3, see, and that would work, right? Because you would have bring the 2 down. Minus 3 times 2 is minus 6. This is minus 1 when you add. Minus 3 times minus 1 is plus 3. And then you would have 0. And then you would be done, because what's this factor? Yeah, it's 2x minus 1, right? Exactly what we have here, right? Okay. So no reason to do any more synthetic division there, right? Okay. Because you know your quotient there is 2x minus 1, so you can immediately see, right, that the other 0 is 1/2. Whew. All right. All right, so I've got one for you. Okay, so this might take us a few minutes here. So we want to find the zeros of this big monster. X to the fourth minus 5x cubed minus 5x squared plus 23x plus 10. Okay, all right, so that's what we're trying to find the zeros of. And you know there can be how many here? Four, right? Okay, so there can be four, and so this may take us some time, all right, to find all four of those. But where shall we start? All right, so what are the factors of our constant coefficient? 5 and 2. So you have plus or minus 5, plus or minus 2, right? And then don't forget 1 and 10. That's it, right? I don't think you can write 10 any other way. Product, right? What about for our leading coefficient? Just 1, right? So that works out nicely. So what about the rational zeros? It's got to be just these divided by 1. So just repeat the p factors, right? So you have plus or minus 5, plus or minus 2, plus or minus 1, plus or minus 10. So you know to start, got to be one of those. How many is that? 8 possibilities, right? See if y'all can find one for me. All right. So you guys look for one. Hopefully I will find 2 different ones. I love this a lot. Different people come up with different heroes here. Yeah, because they're over one. You put it all. It's hard to know first, right? So, oh, you got one? That one. Second. Really, it's kind of guesswork. Start with. Oh, possible. Smart. Last one. Those. Oh, yeah. Start. Yeah, this may still actually Okay, thank you for first. Five. Five. Right, so no. So see, on school. So everyone goes process. All right, let's see where we're at. So let's see where we're at this point. Okay, so I think several people noticed that 5 is going to be a 0. Is that right? So because when you try 5 with synthetic division, let's see, the coefficients are 1, -5, -5, 23, and 10. So bring down the 1 times 5 is 5. Oops, there we get a 0. 5 times 0 is still 0. Now this is -5. 5 times -5 is -25. Add, you get -2. And 5 times -2 is -10. Yay, okay. So indeed, we get a remainder of 0. So we know that 5 is one of our x-intercepts, okay? Now, that's one out of a possible 4, though, because this thing has to be 4. So there could be 3 more, but maybe not 3 more, right? 4 is just the maximum number. Now, look, you're working with a simpler problem now, though, okay? Because now, see, you know that the x to the 4th, etc., you know that factors as, what was our quotient after the synthetic division? It was 1x cubed plus 0x squared minus 5x minus 2. And then we factored out x minus 5. So you see this big polynomial, you've already got it partially factored. It factors as x cubed minus 5x minus 2 times x minus 5. So now you can restrict your attention. You don't have to work from the original fourth degree polynomial anymore. Now you can restrict your attention to this simpler x cubed. You're just looking for the zeros of the x cubed minus 5x minus 2, right? Okay. Now that's still cubic, so you know you still have some work here. If this were quadratic, we would be happy, right? We would be nearly through. But this is still cubic, so we still have some work. I still need to find, hopefully to find another zero, right? But what are my possibilities now? Look, they're restricted because what is the leading coefficient here? 1. But what's the constant coefficient? Minus 2. If you take the factors of minus 2 and divide them by the factors of 1, you're going to get plus or minus 1 and plus or minus 2. So that's all that's left as possibilities, plus or minus 1, plus or minus 2, right? The 10 is not going to work, and we used the 5 once, but it's not going to work again, right? We're down to just this list. Now, let's try one of those. There's only 4. So what do y'all want to try there? -2. So that work? All right, so -2, all right. And what are the coefficients? 1, 0. Don't forget, you don't have an x squared, so put a 0 there. -5 and -2. See if that works. Bring down the 1. 1 times -2 is -2. So we get 0 and -2. That's -2. -2 times -2 is +4, right? -5 and 4 is -1. -2 times -1 is +2. Oh, all right. So Hannah, you already figured it out. Okay. All right. So -2 is another 0. But you may have done. You may on your own. You may have had to do a little trial and error, right? You might not have started with -2. Okay. I probably would have started with 2. All right. So so now we've got this further factor, right? We know it factors as, what is this polynomial? Is that x squared minus 2x plus 1? Is that right? Oh no, -1. Be much better if it were +1. -1 times x plus 2 x minus 5. But that's great now, because now we're down to just worrying about the zeros of this quadratic polynomial, x squared minus 2x minus 1. And we know 2 of our zeros are -2 and +5. All right, so now let's operate on the x squared minus 2x minus 1. That one, if we can factor, we should be able to factor that one by inspection. So unfortunately, x squared minus 2x minus 1 does not factor. That's why I was hoping it was +1 at the end. That would factor really easily. But x squared minus 2x minus 1 is not going to factor. So you're not going to be able to factor that. But that's okay. You don't have to factor it, because you can always do what? Quadratic formula. So now we are going to have to resort to the quadratic formula to find the remaining roots, if there are any. So let's use now the quadratic formula. So let's see, what were our coefficients? We have -b, so that's minus a -2, because the b value here is -2, plus or minus the square root of b squared, so that's -2 squared, minus, be careful with the signs. Sign mistakes really mess students up in the quadratic formula. So you have -4 times a is 1, so that's not a problem, times c, but c is -1, so be sure you put the -1 in there. All over 2 times a is 1. This doesn't look too bad. So I get minus a -2, that's +2, plus or minus the square root of -2 squared is 4. But now what's this second term here? -4 times 1 is -4, times -1 is +4. So you get 4 plus 4 under the radical, and that's a positive number. That's good, because we can take square root of positive numbers. So we do have 2 other roots. They are 2 plus or minus the square root of 8 over 2. What? No, because you would have to divide 2 into both terms.
Okay.
Yeah. But let me show you something here, Amanda, because so the two other roots are not rational roots. They are irrational roots because of the square root of 8. So that's why these numbers don't show up on our list. So Descartes' not wrong. It's just that your remaining 2 roots are not rational numbers, but they have square root of 8, and square root of 8 is not a rational number because that square root of number that's not a perfect square. Irrational means you cannot write it as a fraction. You cannot write square root of 8 as a fraction. If you write it as a decimal, you will get a non-repeating, non-terminating decimal. But it is a number. It's somewhere between 2 and 3, isn't it, right? Square root of 8 would be a little bit less than the square root of 9. Square root of 9 is 3. So it's close to 3, but not quite 3. Okay, now, however, so this is fine. 2 plus the square root of 8 over 2 is one of your roots, and 2 minus the square root of 8 over 2 is another one of your roots. But you can simplify this by hand a little bit. Let me show you. You have square root of 8, but 8 you can write as 4 times 2, right? And the reason you want to do that is you can extract square root of 4 because 4 is a perfect square. So you get 2 plus or minus square root of 4 is 2, and then you get left with 1, 2 under the radical. So you have 2 plus or minus the square, 2 times the square root of 2 over 2. Now, Amanda, now you can do it, okay? See, you can divide 2 into both of the things in the top, right? So now you can divide out the 2. You end up with 1 plus or minus square root of 2. So 1 plus the square root of 2 is the other, is one of the roots, and 1 minus the square root of 2 is one of the roots. So we get 4 altogether. I forgot what they were now. What 5 minus 2, 1 plus the square root of 2, and 1 minus the square root of 2. So if you graph this big polynomial, I don't think I have a graph of this one either, but if you graph this big polynomial, it will cross the x-axis 4 times. That probably means it has how many turning points? See, if it crosses the x-axis 4 times, it's going to have some wiggling, right? How many turning points does that give you? Think about it. It's going to cross the axis, x-axis 4 times. So it goes once, then it has to come back down, then it has to go back up, then it has to come back down, right? To get 4. How many turning points does that give you? 3, yeah. So you're going to end up with 3 turning points here. I think 3 turning points. Remember, you have a smooth, unbroken curve, so it cannot jump from above the x-axis to below the x-axis. It's got to go from above the x-axis to below the x-axis. It's got to go through the x-axis. You can't jump because they don't have breaks in. Polynomial graphs don't have breaks in. Oh wow, I'm out of notes there. Well, let's try one more. Okay, for fun here. So see if we can do this one. Let's see if we can solve this equation. So notice this is not saying find the zeros of a polynomial, but this really is finding the zeros of a polynomial, right? Because if you look at the formula on the left-hand side here, just look at the formula on the left-hand side by itself. What kind of formula is that? Begins with a P. What is that? That's a polynomial, right? Okay, that's a polynomial. So and we've got that polynomial set equal to 0, and so that means we're looking for the x-intercepts, right, of the polynomial. Trying to solve this equation is the same as finding the x-intercepts of this polynomial. Wow. Now this one is terrible, because to start looking for those x-intercepts, what would you have to do? Factor 140. Wow, that's got lots of factors. It's hard to even write them all down. Okay, there are lots of factors of 140. 7 times 14. No, not 7 times 14. I think. So lots of them, right? Okay, and then you've got to write down the factors of 6, of which there are 4, and then you have to take all these quotients. You're going to get a long list all right? That's going to be a big, long list. But let me show you a little shortcut. Let's look at a graph of this polynomial. Because after all, what is it that we're looking for? We're looking for x-intercepts, right? So let's look at a graph of this polynomial. Let me see if I can find a graph of this thing. So you have to make a graph, but let me see if I can make the graph here. So of course you can use your calculator and or you can use Desmos. I'm going to use Desmos because I think I already have a graph made of this if I can get to the right spot. That's not it, right? So let's run together there. Oh no, I'll pass that around. Ah, so that's it, right? That's the graph, isn't it? And are any of those x-intercepts recognizable? Oh, -2. Yeah, this one, I have no idea what that one is. Somewhere between 3 and 4, right? And this one, who knows, right? But this one looks like it's -2. Well, let's make sure. All right. So how would I make sure of that, Amanda? Yeah, synthetic division, right? With what? The -2, exactly. Yeah. So let's see if we can do synthetic division with -2. And that might work because if -2 really is a factor, once you have factored it out, you're going to end up with a quadratic, remember, because we're only starting with cubic to begin with. So let's see if this one works. Let's see, bring the 6 down. 2 times -6 is -12. 11 and -12 is -1. -2 times -1 is that 2, right? And then this is -70, and -2 times -70 is 140. Yay! Okay, right? So that does work. So so we know that this equation is really x plus 2 times 6x squared minus x minus 70. Now there's two other, we saw them in the graph, right? There's two other x-intercepts. One is right there, a little bit less than -3, and then another one a little bit more than +3. Don't look like they're going to be whole numbers, but how do we find them? Well, try to factor this. Looks like that's going to be tough to factor. But if we can't factor it, we can use what? Yeah, the quadratic formula, right? Okay. So use the quadratic formula. You're going to have kind of ugly coefficients there, but you know, that's life, right? But with a calculator, won't be maybe all that bad. So there they are. There are the other two x-intercepts. So apparently when you simplify this, you'll come out with something, two numbers, one a little bit less than -3, and then one a little bit bigger than positive. Let's see, this is 1 plus or minus the square root of 1. -1 squared is 1, right? This is going to be -4 times 6 is -24. -24 times -70. Y'all do that for me on the calculator. What's 24 times 70? $1680. All that over 12. So we have 1 plus or minus the square root of 1681 over 12. So with our calculator, we can get a decimal approximation for these two numbers. Let me try one of those. So let me try 1 plus the square root of 1681 divided by 12. Hope that comes out to be something like 3. Oh, that's interesting. 1681 is a perfect square. Who would have guessed? I think its square root is 41. Yep. Oh, so that's not bad at all. Oh, so that means this expression factors. Well, you know, we would have been spending all day trying to factor 6x squared minus x minus 70. Okay, so there the quadratic formula is really useful. So one of your roots is 42 divided by 12. Yeah, that's a little bit more than 3, right? And the other one is minus 40 divided by 12. That's a little bit less than minus 3. Okay. Nice. Yes, Jen. No, you won't. You won't be required to make a graph. So I would ask problems differently than this. Okay, but I did want to point out, right? Okay, that don't forget that graphing is another way of helping you understand what polynomials look like, right, or what equations look like as well. Correct. So don't want to forget that as a tool to help you sometimes. Okay. Well, we're out of time for today. Well, we learned a lot today. Really know a lot about polynomials now. That's very useful knowledge. All right, so I'm going to see you next time. We'll do a little bit more practice with this, okay? Before we go on to our final couple of topics. All right. See you guys on Wednesday. See you guys at home on Wednesday.